Good day. In this lecture, we will deal with tensile testing of textile materials. It is common for fiber, yarn as well as fabric testing laboratory, or for the theory course textile quality evaluation, fabric quality evaluation, or fiber and yarn quality evaluation. This tensile testing is a common topic. The two important books related to textile quality evaluation or textile testing are these two books. This is not only for tensile testing of textiles, for any testing of textiles, these two books will give you a basic understanding and a good knowledge in the testing of textile materials. This is the appearance of the book. You can have the soft copies of the book and learn through that. This is the Principles of Textile Testing book. The author is J.E. Booth, and the Physical Testing of Textiles by B.P. Saville. This is another book that you have to refer for the theory as well as for the laboratory course. The tensile testing topics are in chapter 8 of the book by J.E. Booth and chapter 4 and 5 of the book authored by B.P. Saville. So these are the chapters that you have to refer in these books for tensile testing. Tensile testing is a very important topic. It is common for the principles behind any tensile testing instrument is common, whether it is fiber, yarn, or fabric, or garment, seam, anything you test. The principles behind remain the same. It is not only for textiles. The principles are common even for tensile testing of other materials other than textiles. Let us go into the topic tensile testing. We have a material. You can see the black color is a textile material, maybe a textile fiber or textile yarn, or maybe a fabric. This is held between two jaws, and if you apply a force along the axis, the force is given in the direction of the arrow mark. The force applied is parallel to the axis of the material. So you have a central axis. So you have a material of length L. Now you are applying force along the direction parallel to the axis. So F is applied parallel to the axis of the material. So if you apply a force, then there will be a change in the length of the material. So there will be an increase in the length dl. So this change in length is dl, and the actual length was L after applying a force. This, if you apply the force in this direction, then it is called as tensile test. Usually for textile materials, force is applied along the axial direction. Because textile materials are anisotropic, you do not get the properties when you apply in the transverse direction. You see F is in the axial direction. If you apply force perpendicular to this direction, then the properties will be different. But usually textile materials, the force is applied in the axial direction, which is called as tensile test. And the properties are different in the axial direction and in the transverse direction. That is why these materials are called as anisotropic materials. Isotropic means in both the directions, axial as well as transverse, the properties will remain the same. Whereas anisotropic materials, the properties are different. Textile materials are anisotropic in nature. Tensile testing is done for fibers, yarn, and fabric. Fibers, the jaws are different. It has to be very delicate, as the fiber is very delicate. Yarn, you usually have jaws which are pneumatic in nature, and for fabric the jaws are different. So we do tensile testing for yarn, fiber, and as well as fabric. So what is the need or what is the reason for testing a material for its tensile properties? So to find how much load it can withstand, how much load, where it breaks. When you have a, say, I have given here rope. If you have a rope, and then say if you have a rope like this, if you have a rope like this, if you apply a force, which where it will break, how much load this wire, this rope can withstand. So that can be known by testing the material for its tensile properties. So to know where it breaks, breaking point to be known. When you have to know the breaking point of the material, so that you can know how much load it can withstand, where you can use that material. So in how much force you can apply in weaving. So in weaving, in the shedding process, the yarn is going up and down, and it is subjected to a very high stress. So whether it will break or not, if you give that much stress, it should perform in the weaving. If all your yarn breaks in the weaving, then no point in producing a yarn of which will break. If you want to produce a fabric, you have, if woven fabric, you have to weave it. If it does not withstand the stresses that are caused in weaving, then no use in producing yarn. So during the production, it has to survive. Maybe in use, apparel use, there may not be very high tensile forces that are acting. But in sewing threads, when you have some joints in the hands, in where a seam is there, where it is stitched there, if you apply, the sewing thread should have the required strength. Only then it will not break and peel off. In for normal apparel applications, you may not require that much strength. But in technical applications, technical textiles like seat belts, ropes, and geotextiles, this tensile testing is very important, and very high strength requirement is required for those textile materials. In apparel and household materials, not very high strength of yarn is required, but to produce apparels during weaving, that yarn requires certain amount of strength to undergo the process. So these are the reasons for testing any material for its tensile properties. So next we'll see what are the factors that affect the strength of a textile material. So what first and foremost is the fiber type. Based on the fiber, cotton will have one type of strength, polyester has one type of strength, then one value of strength, and jute has one value of strength, nylon has one value of strength. What is this? Usually the range is common. Cotton in this range, polyester in some higher range, nylon in some range. So this is based mainly on the molecular arrangement. So molecular arrangement is the one which decides the base first strength of the fiber. And the orientation of the polymers, you would have learned in your textile fibers or physical properties of textile fibers subject, or fiber science. I don't know the name of the subject exactly, but you all have learned in your third semester regarding the physical properties of the textile materials, in which you have already had this tensile properties. You have that as the major topic, and I'm just revising those things here. It is not a new topic that we are learning here. So the polymer arrangement inside the fibers. You all know the fiber inside has many number of polymer chains. Each molecules are arranged in a linear fashion, which forms the polymer, and the number of repeating unit is called as your degree of polymerization. So your degree of polymerization, your crystallinity percentage and amorphous percentage, how well the polymer chains are arranged along the axis of the, if it is along the axis of the fiber, then it is oriented. How better it is oriented to the axis, in which angle it is oriented. If it is oriented in this direction, that is during the drawing process in the synthetic fiber manufacturing, you have the drawing process wherein you get a better orientation. So this will result in a good fiber strength. So if it results in a good fiber strength, then you can apply as much amount of force as required. So this the force that is applied is with the fiber withstands by an internal molecular change that is happening inside, which is the stress that is balancing by the opposite force that is in the in happening inside the molecular structure. So this molecular structure are and the orientation and the length of polymer chains and n number of factors affect your strength of the textile material. This is the first base. After that, you are using that fibers and producing a yarn. So the uniformity of the yarn along its length, or the fiber itself, the fiber uniformity of the fiber along its length improves the strength of the textile material. So if there is a weak place, then it cuts. If in a yarn, if there is some weak point, there it will break. So uniformity is very much required for a textile material. We will understand this by knowing on weak link effect in the next in the coming slide. And then we have already seen the fineness of fiber. Finer the fiber, more number of fibers will be there in the yarn cross section. So there will be more cohesiveness between the fibers. So when you mechanically twist in ring spinning, then it will produce a stronger fiber. This we discussed during the fiber fineness lecture. And next, as all our textile materials, most of our textile materials are moisture absorbing. The amount of moisture present in the textile material changes it has an influence on the strength. For example, if it is a cotton fiber on absorbing moisture, to some extent, the strength increases. Whereas viscose fiber, when the moisture is absorbed, the strength decreases. So according to the type of material, the moisture absorption value, according to its moisture absorption, the strength values are different. The moisture is absorbed from the atmosphere, hence the relative humidity or the amount of moisture present in the atmosphere has an influence on the strength of the textile material. Next is temperature. Temperature, say if you increase the temperature to a very high extent, your synthetic fibers may have some, see, before melting itself, the polymer chain starts moving apart due to the increase in temperature. So due to that, there is an internal change in the molecular arrangement. So which results in the change of the fiber. As our polymer chains and the molecular arrangement is the reason for the strength, temperature affects the orientation and other properties. So, the temperature has an influence on the strength of the textile material. In normal temperature conditions, maybe it is not changing much. That is why during testing, as mentioned in the earlier lectures, relay RH and temperature are to be maintained in the testing atmosphere. I remind you the temperature is 20 and I'm sorry, temperature is 65 degrees centigrade and I'm sorry, temperature is 20 and relative humidity is 65%. So that are maintained in the testing atmosphere so that the influence of both the relative humidity and temperature are neutralized. Then the elasticity of the material. Sometimes the material may not break in that strength. It elongates to a very high extent, only then it breaks. So elasticity also has an influence on your strength reading. Now we'll see on the uniformity of the material along its length, how that affects your strength. Now we'll try to understand the effect of uniformity. Better the uniformity of the yarn, the better will be the strength. So uniformity is an important parameter. So that effect of the length of the specimen is called as weak link effect. We'll try to understand that through this. So you are plotting the strength. You have your y-axis where your strength is plotted. So it is 0 starts from here. So we have you are plotting the strength. So you have plotted the strength and see this you have S1, In S1, the strength is very low. S2, next to the strength, the weakest point S2, then S3 and S4. You have many weak points. The top are all points which are having high strength. These are the points. Along the length of the yarn, there is a weak spot, there is a stronger spot, there is a weak spot, stronger spot, weak spot, stronger spot, and it goes on like that. The yarn, if you totally have the total length of the yarn, then the weakest point is the one that breaks. So, the weakest spot is the one that breaks if you take this total length of the yarn. So if you take a smaller length till S2, if you have a smaller length of the yellow color line, then it will break at S2. That because it is the weakest point. If you take a longer length of yarn, then it will break at S1. The orange color line, if you take a longer length of yarn, then it will break at S1. Then if you further increase the length of the yarn, then it will break. Say if you take a length of length 3, sorry. If you take a length of L3, then the yarn will break at a point at this point, at the blue color point here. I have not given as S1, S2, as S3. It will have a still lower value. If you so from this we understand that if the length of the material that is tested increases, then there is more probability that you will have a more weakest spot. So the weakest spot will break first. So that is the strength, breaking strength of the yarn. So longer the length of the yarn that is tested, then lower will be the breaking strength that is recorded. This effect is called as weak link effect. So the weakest link breaks first, and the number of weak links will increase. The probability that there will be probability of weak links will increase if the length of the material that is tested increases. This is called as weak link effect. So gauge length of the when you test a material, the length of the material that is tested is called as gauge length. You will take a material and test 12 inches of material. You will take and test. The length between the two jaws is called as gauge length. If you take, you may take 8 inches, 10 inches, 12 inches, like that. You can take different length of materials. The longer the length, then there will be more probability that there will be a weakest spot in the if the longer the length, more weak spots are probable, then the breaking strength decreases because the yarn breaks at its weakest spot. This effect is called as weak link effect. That is why they have kept a standard length for testing, that is 300 mm is the standard length that as per ASTM for testing a yarn sample. In tensile testing, there are many topics, but these are the important topics which we have as experiments in the laboratory, and or many other few are there in the laboratory, few are not there in the laboratory experiment, but still you have to learn that for understanding tensile testing. For the theory portions, many other experiments are also there. For fiber strength, the fiber can be tested in a single fiber form. You can take a single fiber and strength, or you can take a bundle of fibers and test. So fibers, the material is taken as a single one or a bundle. Usually, man-made fibers you go for single fiber strength, and for a as it is more uniform. But for textile natural materials, you go for bundle fiber strength. Then in yarn strength, you have single yarn strength, wherein a single yarn is kept under the jaw between the two jaws and tested. Skein strength or Lee strength, wherein a bundle of yarn is tested. A Lee has 80 threads in it. The total length of the yarn is 120 yards. you use a wrap reel. Hope you all have seen a wrap reel, wherein you form the Lee, and that Lee is taken for testing, and you find the count strength product from this Lee strength. Next is yarn impact strength. Uh, you find the work of rupture directly in the yarn impact strength. And using many terms, we'll see the definitions for the terms in the forthcoming slides. Then in fabric strength, strip stress, ravel strip test, grab test are common tests that are done for a fabric. These three variations are based on the size of the sample that is kept for testing. Next, we'll see the various tensile testing terminologies. You would have already learned in your fiber physics these terms, but a clear understanding of that is required before going into the various tests, because this is common for fiber, yarn as well as fabric. We are repeating it again here. So load is the force that is applied to the material. When you may load and cause extension, or you may extend the material, which causes a stress in the sample. So that force that is applied is called as load. It may be in kgs or Newton. So then next, the breaking load. The load that is applied at the time of break is called as breaking load. Then stress is a common terminology used in other, you would have learned this in your applied mechanics subject, physics, those subjects. You would have heard this term stress. Stress is force per unit area, unit cross-sectional area. Since we are unable to find the cross-sectional area, as I mentioned, we are unable to find the diameters, difficulties in finding diameters we discussed in our fiber fineness experiment. That is why we go for fiber fineness itself. We test for the linear density of the material. We do not test the diameter, but the linear density and diameter are proportional. Hence, so we can't go for stress measurement. So we go for another term, specific strength, which is force by linear density. Force divided by linear density. Stress is force by cross-sectional area. Specific strength is force by linear density. So we have centinewton because the force value is very small with regard to fibers or yarns. So it is given in centinewton instead of Newton. Newton you will use if it is a very high strength material, divided by x or linear you can use. So then we will see what is tenacity, the other breaking length, elongation, strain, extension percentage, breaking extension, gauge length, and many other terms are there. I want you to read the other terms as well in the book. We will go through few terminologies and how you find them. The first is load, the force that is applied. It is called as force or load. Next is breaking force. The load at which the specimen breaks is called as breaking load or breaking force or breaking strength. It is the maximum tensile force that is recorded while extending a sample to test uh, to till your breaking point. So usually sometimes after reaching a maximum, then it may slightly extend and then break. The maximum point is taken as the breaking force. The unit is Newton, centinewton or grams, that is commonly used in textiles, sometimes kgs. Next is stress. Stress is force per unit cross-sectional area. We do not use this in textiles. Instead, we use, this is not, so this is force in Newton divided by linear density. No, this is not linear density here. It is wrong. So it is not linear density. It is, what is that? It is area. Force by area. Unit is right, but the term here is wrong. So I want you to change. This is area. So it is Newton per mm square or gram per centimeter square. So this is not used for textile materials. You can see here it is not for textile materials. Here common in textile materials is specific strength. So we have our specific strength. So specific strength or specific stress, which is strength ratio of strength by linear density or force by linear density. Force may be in grams and linear density may be in linear or x. So these are the various units of measurement of specific stress. Next is tenacity. Tenacity is specific stress at break. Like load at break is called as breaking load. Similarly, specific stress at break is called as linear tenacity. So this is a very important term that is used in textiles. The tenacity of textile material is very important, and this has to be found for any fiber yarn to compare with the other materials. So breaking force, this you will find out in your experiments. Tenacity, gram by linear density. Your units are gram by linear, gram. Newton per tex, gram per tex. You can have tex, gram by tex. You can have Newton per tex, centinewton per tex, centinewton per linear. All these terms you can use for tenacity, similar to your specific strength. Next is elongation. Elongation is the change in length. Increase, you have this much length, the material extends to this much. So, or you have like this, material extends. This change in length is called your elongation. It may be in centimeter or meter. Then usually elongation directly, instead of giving it directly, you have to convert it into strain, because the initial length may be different. So you have to convert into strain. Strain is elongation divided by original length. So this is the change in length divided by original length. So there is no unit. The centimeter and centimeter gets cancelled. So strain has no unit. If strain is expressed as a percentage into 100, then it is extension percentage. Sometimes they call it as strain percentage also. So strain percentage or extension percentage is the term that is used. The strain expressed as a fraction. Instead of fraction, it is told as a percentage. This is a common terminology used for measuring the strain. So next is an important term, work of rupture. This term is useful in industrial textiles. It is the energy required to break the material or the total work done in breaking. So if you have a stress strain curve, x and y axis, the area under the stress strain curve is called as work of rupture. So the area can be found by integrating 0 to break force dl. This is length, change in length, the force into force. So you will get the work of rupture. The unit is joules. This is very important term in industrial textiles.